Hi everyone, my name's Poppy and I'm a PhD student in the Goffin lab. I'm going to present today work that everyone you can see listed here has been part of. We have studied the Goffin's ability to learn to discriminate between weighted objects. Now, animals' ability to discriminate based on weight, which is a type of proprioceptive information, is less studied than discrimination within the other senses, such as vision. But the weight of objects is important in some natural decision-making contexts, very notably that of extractive foraging. So here a food resource must first be extracted from an outer shell, for example, and this is costly, both in terms of time and energy, so it only makes sense to do this if the food resource is actually worthwhile. But there's no visual access to this food resource, so another cue needs to be used to assess the value of it. Now, a full nut will weigh differently from an empty nut, so weight is a good cue to be using. We also know that individuals that are using stone hammers to crack open nuts, they will choose the most effective stone tool based upon its weight. So as well as looking at these natural behaviours, we can also study a species' ability to use weight information and learn associations based upon weight information by giving them a classical discrimination learning task where the objects are otherwise identical but differ in terms of their weight property. So here individuals will be tested until they reliably choose the correct version of an object based upon its weight. Now, so far, only primate species have been tested in this way. And there are a few different methodologies that have been used. In two early papers, chimpanzees and monkeys needed to choose just one of a pair of heavy and light boxes. And in the Schrauf and Kuhl paper, bonobos, orangutans and gorillas were given 12 objects, 6 of them heavy, 6 of them light, and needed to return the correct version to the experimenter. And then in a study by Povinelli, his chimpanzees were required to learn to place a heavy and light object in a tray of a correct colour according to its weight. Now, across all of these studies and species, individuals have required median trial numbers ranging from the 300s to 1,100 to meet the experimenter's criterion. So this shows that it's not a trivial task. So no bird species had been tested in this way, but there is some good evidence to show that birds can and do use weight information because, of course, many species are extractive foragers. So two studies that I mention here, they provided wild birds with options of seeds and nuts differing in their weight, and they found that the birds preferentially took the heavier versions of the food items available to them. If we look at weight information use in a problem-solving context, Megan Lambert and colleagues found that when Kea and New Caledonian crows were given the opportunity to explore these weighted blocks, some individuals performed above chance on a platform task after exploring them, which suggests that they did learn something about the functionality of these blocks in terms of their weight. And then I'll also mention the training phase of a study by Lambert et al. So they gave New Caledonian crows collections of visually distinct heavy and light objects, and individuals had to learn to always choose either the heavy or the light options. And they learnt this rule quickly and they transferred it over to new visually distinct objects. So although this isn't a methodology that's comparable to the weight discrimination tasks I just mentioned, it does suggest that this species is able to learn arbitrary associations based upon weight. Now, we wanted to begin to remedy this lack of comparable weight discrimination research outside of the primates. And the Goffin's cockatoo is a fantastic species in which to do this. In the wild, they are extractive foragers. They feed on coconuts, tubers that they dig up from the ground, and here they're pictured feeding on some fruits which form part of their diet. In the lab, they have shown primate-like tool use, and within tool use, proprioceptive feedback is important. So we had two main research questions. Number one, of course, are the Goffins able to discriminate between our objects, which are visually identical but weighed different amounts, and our objects differed by 20 grams, which is appropriate for a bird whose size is between 250 and 300 grams. Secondly, given that it's going to be very rare that they experience food items which are visually identical as well. We were interested in their learning speed when objects also differed with in terms of a stable colour cue. And secondly, we wanted to ask what would they learn about object weight during this experience, given that they didn't need to rely upon the weight difference to learn the task, they could just use the colour cue. So we gave our subjects a really simple choice task, and there were two versions of this task. So in the weight-only task, objects were visually identical, differing only in weight, but in the colour weight task, the objects additionally differed in their colour, and the colour weight combinations were stable. Also, we counterbalanced the colour weight combinations, so blue heavy or blue light, across all of the subjects that had this colour weight task. We had two groups, so the pre-experience group were first given the colour weight task before they transitioned to the weight-only task, and the test-only group only ever received the visually identical objects. We tested subjects in this way, so both groups were tested until they met criterion in their respective task, and this criterion was 9 out of 10 overall or 8 consecutively correct choices. And then after this point, we gave all subjects 5 sessions, so 50 trials of the weight-only task. This is what our trial, our task looked like. So first of all, the subject was asked to move both the heavy and the weight objects presented to them to separate dishes. And for doing this, they received a sunflower seed, so a low value reward. And then in the choice phase, in the second step, they were required to choose the correct object to give to the experimenter, and if they were correct, they received a piece of cashew. This is a trial in action. So in the trial that I just showed you, we saw Figaro in the second step go and pick up the incorrect object first and put it down to then pick up the second. Now we called this switching behaviour, and in fact some subjects switched 3 or 4 times in their trial before making their final choice. So we had a couple of post hoc questions centred around whether this switching was functional. So firstly, we asked whether switching behaviour influenced the subject's probability of success, and are subjects more likely to switch if they first picked up an incorrect object. So we found that pre-experienced subjects reach criterion more quickly than test-only subjects. So an average trial number of 40.8 trials for the pre-experienced group with the colour weight task versus an average trial number of 60.6 for the test-only group. But in the test-only group, there was one individual that didn't meet criterion within the 10 sessions that were given to them. Now, when we analyse the same data with a GLMM, we do find a significant difference. So the pre-experienced subjects were significantly better on that colour weight task than the other subjects on the weight-only task. To answer our first question, whether the Goffins can discriminate between objects based on only weight, we analysed the data from the plateau sessions, and we found that this performance, 77.6 correct in the pre-experienced group and 90% correct in the test-only group, this performance was significantly above chance. Now, even though the pre-experienced group in terms of raw numbers didn't perform as highly as the test-only group on these plateau sessions, in fact, these subjects were more likely to be correct comparing these 5 sessions with all of the sessions of the test-only group. So they were more likely to be correct on this task, which does suggest that they learned something about the weight difference between the objects and that they could use this once the colour cue was taken away. Our post-hoc questions then about the switching behaviour. We found that yes, switching behaviour did increase probability of success, and that's even though switches only occurred in about 14.5% of all the trials. And also subjects were more likely to switch if they picked up the incorrect object first. To come to our conclusions then, well, firstly we conclude that the Goffins are able to discriminate between objects which only differ in their weight, but they will learn to do this more quickly when a colour cue is additionally available to them. We believe our results show that, or suggest that the Goffins are learning about the object weight even when they don't need to in this colour weight task, because the pre-experience group outperformed the test only group in the weight only trials, and because the task is so simple and doesn't require learning to achieve it, we think that this result isn't explained by having previous practice with the task. Lastly, our results are suggesting that the Goffins are able to learn to discriminate these weighted objects much more quickly than any of the primate species tested so far. So do our results suggest that birds are in fact more sensitive to weight at a group level than primates? This could reflect a difference in the lifestyles. So of course, when birds are transporting objects, they're mainly doing this in flight, which is more energetically costly. So it might be that they have reason to pay more attention to the weight of objects. And of course, many birds build nests, and this requires many trips back and forth transporting objects. So given that all species that lift objects are going to be perceiving the weight of that object in the sensory motor system, what we're doing by looking at the performance on a cognitive task based upon weight information, we are asking what has happened perhaps in this black box in between the perception of the weight and cognitive performance. So have we perhaps seen an interplay between environment and cognition here? However, there could be an alternative explanation which contributes to the difference that we've seen, and that could lie in differences between methodologies. So certainly it seems that there is quite a difference between our choice study and the sorting study by Povinelli. So in a choice study, which I think is most similar to the studies by Kluver, McCulloch and Schauf and Kuhl, the individuals have both of the objects available in that trial to lift if they want to. In our study, we ensured that they move both objects to experience the weight of them. In a sorting study like Povinelli's, the individuals only have access to one of those versions of the objects. So there might be an effect of handling time and opportunity to make comparisons that would influence how successful an individual is, and also related to that, the salience of the difference between the objects given how recently that difference has been experienced. What next then? Well, if we want to explore whether this interplay between environment and cognition is there, of course, it would be fantastic to carry out more tests with comparable tasks between different species and groups. So one suggestion is that we test primate species in this choice study methodology that I've presented here, which is good because it ensures that the individual has moved and interacted with both of the objects before they make their choice. And of course, it would be very beneficial to test further birds on this task to get an idea of how different species within the group will perform. And with that, I will give you references and say thank you very much for listening.